In this video, we will do matrix inverse and transpose example, which we will use matrix inverse properties and matrix transpose properties. We will do two examples. First one of this is this one, and the second one, which we will see that we cannot use matrix inverse properties. So in this first example, let A equal to this matrix and B to this matrix. We need to answer these two questions, find if possible this, and find C if we have this equation. Now, for the first one, find if possible this. So here you can see here we have a square. A square here, it's not mean that you take the square of each element. No, you have to multiply A multiply by A. So A matrix multiply by A matrix. Sometime A square equal to the square of each element here, but in general, we have to multiply A multiply by A. Then we have to find this, and you can see here we have a scalar or a number multiplied by a matrix. Since we have the whole thing transpose, this two, it will go out. So it will be A transpose. Now let's solve the first one. I will write this again here. A square, which is this one, minus, I will write here this one again. So 2A and the whole thing transpose equal. So I have to open this one, which is A multiplied by A minus. Here I have to take this scalar out, so it will be 2, and the transpose, it will go to this A. Now, since we open everything here, so let's write this A. Since we have here A multiplied by A, so here I have to write here A and here A. 1, 2, 1, 3. 1, 2, 1, 3. I'll write it again. 1, 2, 1, 3. Because here we have A multiplied by A minus here 2. Now I will take the transpose of A. So what is the transpose of this A? So we have to change the row to column. So the first row, here it will be first column 1, 2. Here it will be 1, 2. And here the second row, it will be the second column 1, 3. Here it will be 1, 3. Equal, since this 2 by 2 and here 2 by 2, so here it will be 2 by 2, because here 2 by 2 and here 2 by 2. The result matrix, it has to be here this 2 and here 2. I will change the color. So here this 2 and here this 2. That's why here we have 2 by 2, because here 2 and here 2. And here the number of columns in the first matrix, it has to match the number of rows in the second matrix if you want to multiply them together. So here to find the first element here, we have to multiply this row by this column. Let's write it here. 1 multiplied by 1, which is 1, plus 2 multiplied by 1, which is 2. 1 plus 2, which is 3. So here I have to write 3. To find here this element, we have to multiply this row by this column. 1 multiplied by 2, which is 2, plus 2 multiplied by 3, which is 6. 2 plus 6, which is 8. So here I have to write 8. 8. To find here this element, we have to multiply this row by this column. 1 multiplied by 1, which is 1, plus 3 multiplied by 1, which is 3. 1 plus 3, which is 4. So here I have to write 4. To find this element here, we have to multiply this row by this column. 1 multiplied by 2, which is 2, plus 3 multiplied by 3, which is 9. So the answer will be 11. 2 plus 9 equal 11. So here I have to write 11. 11 minus, so here I have to multiply 2 multiplied by this matrix, which is 2 multiplied by 1, which is 2, 2 multiplied by 1, which is 2, 2 multiplied by 2, which is 4, 2 multiplied by 3, which is 6, equal 3 minus 2, which is 1, 8 minus 2, which is 6, 4 minus 4, which is 0, 11 minus 6, which is 5. So that's it. We found this A. Now let's solve B. Now we want to solve B. Find C if we have this. To find this C, we have to have only on this side C. How to do this? We have to multiply here by A, since we have here A inverse, so it's exists. So we have to multiply here only by A, and if we multiply here by A, here we have to multiply by A as well on both sides. So this here it will be identity, so we can simplify it by not write identity. Then here we have to take this B transpose to the other side. Then we have C on the left side and the rest on the right side. You can pause this video now and you solve it by yourself. Then you can compare your solution by my solution. Now let's solve it. Now I will write it again. B transpose plus C and the whole thing multiplied by A inverse equal B transpose. Now I will write here if and only if. If and only if, that means you can simplify this one to here, and of course you can back again. So that's here, that's why here the arrow here and here. So you can go from here to there, and you can go from here to there as well. Now let's multiply both sides by A from the right. So here we have to multiply here by A and here by A. You cannot multiply here by A and here you multiply A by the left side. No, it will not. Correct. So now let's multiply A from this side, from the right side. So it will be B transpose plus C A inverse, and I will multiply by A equal B transpose A. Now the same thing here, I'll write if and only if, and of course we know that this equal to identity with size 2 by 2, because here A 2 by 2, so that's why here identity 2. So here I have to write B transpose plus C and the whole thing here. This will simplify to identity equal BT, which is B transpose multiplied by A. And I will write it here again. I can write it from there, but I prefer to be here. So now we have to simplify this. Since here we have identity, anything multiplied by identity, it will be the same. So here it will be the same. So BT plus C, it's like multiplied by 1, so it will not affect anything, equal BTA. And here I have to write again if and only if. To find this C, we have to take this matrix to the other side. So here, since here positive, it will be negative. So here it will be C equal B transpose A minus this BT. So we found it like this. So the formula to find C, we have to compute this one. Therefore, C equal bt. I will write here this one again, a minus bt equal, to take the transpose of this b. How? Since here 2 by 3, here it will be 3 by 2. Or you can find it like this. The first row, it will be the first column. So let's write it here like this. 1, negative 1, 2. 1, negative 1, 2. 3, 2, 0. 3, 2, 0. You can see here the size 3 by 2 and here 2 by 3. So you have to swap them, because we will use this one in the second example. So make sure that you understand, if you want to take the transpose of a matrix, these number, they will swap. So since here 2, 3, here it will be 3, 2. So you have to switch it. Multiply by a, which is this one. 1, 2, 1, 3. Minus bt, which is the same as we did here, b transpose. So we have to write this one here again. 1, 3, negative 1, 2, 2, 0. Since here 2 by 2, so since this one the same as this one, so we can multiply them together. Therefore the size of the result matrix 3, 2. So 3 rows and 2 columns. 3 rows and 2 columns. Why? Because here 3, 2, because here 2 and here 3. So that's why the size 3 by 2, 3, 2. Let's back to the color. To find this element here, we have to multiply this row by this column. 1 multiplied by 1, which is 1, plus 3 multiplied by 1, which is 3. So 1 plus 3, which is 4. So here I have to write 4. To find this element here, we have to multiply this row by this column. 1 multiplied by 2, which is 2, plus 3 multiplied by 3, which is 9. 2 plus 9, which is 11. So here I have to write 11. To find this element here, we have to multiply this row by this column. Negative 1 multiplied by 1, which is negative 1, plus 2 multiplied by 1, which is 2. Negative 1 plus 2, which is 1. So here I have to write 1. To find this element here, we have to multiply this row by this column. Negative 1 multiplied by 2, which is negative 2, plus 2 multiplied by 3, which is 6. Negative 2 plus 6, which is 4. So here I have to write 4. 4. To find this element here, we have to multiply this row by this column. 2 multiplied by 1, which is 2, plus 0 multiplied by 1, which is 0. 2 plus 0, which is 2. So here I have to write 2. To find this element here, we have to multiply this row by this column. 2 multiplied by 2, which is 4, plus 0 multiplied by 3, which is 0. 4 plus 0, which is 4. So here I have to write 4. So now we have computed this matrix, which is the result of multiplying this matrix by this matrix. Now we have to write this minus this matrix here, minus 1, 3, 1, 3, negative 1, 2, negative 1, 2, 2, 0, 2, 0. Now we have to subtract this matrix with this matrix. of course it will be the same size. 4 minus 1, which is 3. 11 minus 3, which is 8. I will close this bracket. Now 1 minus, here with minus 1, here minus with minus, it will be positive. It's like 1 plus 1, which is 2. 4 minus 2, which is 2. 2 minus 2, which is 0. 4 minus 0, which is 4. So that's it. We have compute C. So by using this formula, we compute C. So here we have just substitute the formula, which is B transpose, which is the transpose of this one. Then we substitute A. Then we substitute again B transpose, which is the transpose of this one. We got this C. So now if you substitute this C here, and if you compute A inverse here, and if you put B transpose, which is the transpose of this one here, so if you compute these three things, which is B transpose plus C, then you multiply by A inverse. Of course, you have to compute A inverse as we did before, the inverse of this A. You will get B transpose. So if you want to check your answer, you can do it. So that's it. Now let's solve example number 2, which is down. Now let's go down. Let's solve example number 2. Let A equal to this and B equal to this. Find a matrix C such that CA equal B transpose. Now, to find this C, as we know before, you have to multiply A inverse from the right on both sides, but here we have here not square matrix. This matrix is 2 by 3, which is not a square matrix. So you cannot multiply A inverse both sides from the right because this one it's not square matrix. To find the inverse of a matrix, it has to be a square matrix. It's mean like 2 by 2, 3 by 3, 4 by 4 matrix, but not as like this. How to solve this one? We have to solve it like this. We have to write this one again. So C A equal B transpose, and I will put bracket. I will put here X because I will write here the size. The size of B transpose. What is the size of B transpose? Let's find first the B transpose. B transpose, it look like this. The row, it will be column. So 1, 0, 1, 0, 1, negative 4, 2, negative 5, 2, negative 5. So it will be 2 by 3. Before it was 3 by 2. So here the size, here I write it here in this color. Why I write it? Because I want you to visualize the size. Here 3 and here 3. I will change the color. So here we know this 2. I have to write here 2 and I will change the color again. We know here 2. So I write here 2. Now I will back to the purple color. Since here we have 2, I have to write here 2 because this it has to match this and this it has to match this. Now I will change the color. Since here we have 2, here I have to write 2. As simple as this. So this one it has to match this one. This one it has to match this one. I will back to the blue color. So it's very easy to find the number of rows and number of columns of the matrix C. Since here we have here 2, we write here 2. Since here we have 2, we have to write here 2. And you have to keep in your mind here B transpose, the size of B transpose, not the size of B. The size of B 3 by 2, but the size of B transpose 2 by 3 as we wrote it here. And I put bracket to make sure that you understand the size of this matrix. So let the matrix C equal to this C1, C2, C3, because we don't know the element of C. Now let's write this one again, but in matrix, not like this. C1, C2, C3, C4. C1, C2, C3, C4. Now let's write A, which is this. 2, -2, -1, 3, -1, 1, 3, -1, 1, equal, because here equal. Now I have to write B transpose as we compute it here. 1, 1, 2, 1, 1, 2, 0, -4, -5, -4, -5. So here, this B transpose. This column, this row, this column, this row. Now, let's multiply this matrix by this matrix. Because if we multiply this matrix by this matrix, you can compare this each element by this, then you will solve it by finding C1, C2, C3, C4. Since here 2 by 2 and here 2 by 3, the matrix here it has to be 2, 3, 2 row and 3 column. So I write it like this. To find the first element here, we have to multiply this row by this column. C1 multiply by 2, so I will write it here 2C1, C1 multiply by 2, 2C1 plus C2 multiply by 3, which is 3C2. So this one here, the first element, we have to compare this element by this element. Now, to find the second here entry here, we have to multiply this row by this column. C1 multiplied by -2, which is -2C1 plus C2 multiplied by -1, which is -C2. To find here this element, we have to multiply this row by this column. C1 multiplied by -1, which is -C1 plus C2 multiplied by 1, which is C2. Now I will close this bracket. To find this element here, we have to multiply this row by this column. C3 multiplied by 2, which is 2C3 plus C4 multiplied by 3, which is 3C4. To find this element here, we have to multiply this row by this column. C3 multiplied by -2, which is -2C3 plus C4 multiplied by -1, which is -C4. To find this element, we have to multiply this row by this column. C3 multiplied by -1, which is -C3 plus C4 multiplied by 1, which is C4, and this equal 1, 1, 2, 1, 1, 2, 0, -4, -5, 0, -4, -5. Now we have to say this one equal to this one, 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 this one equal to this one. And each one I will call equation 1, equation 2, equation 3, equation 4. So here equation 1, equation 2, equation 3, equation 4, equation 5, equation 6. And you can see, since we don't have an inverse, it will be a long story here. Let's go a little bit down. So I will call this 2C1 plus 3C2, which is this one, equal to this one, and I will call it 1, and this one here, negative C1, I will write here not plus negative, I will write immediately negative C2 equal 1, and I will write this equation number 2. Equation number 3, negative C1 plus C2, negative C1 plus C2 equal to 2. I will call this equation number 3. And here 2C3 plus 3C4 equal to 0. I will call it equation number 4. 2C3 plus 3C4 equal 0. I will call this equation 4. Negative 2C3, negative 2C3. I will write here immediately negative because plus negative will be negative. C4 equal to negative 4. I would call this equation number 5. Negative C3, negative C3 plus C4 equal negative 5. I will call this equation number 6. Let's go a little bit down. Now we have to add these equation or subtract them to find C1, C2, C3, C4. The easiest way to find C1 and C2, you have to add this equation by this equation. Because you want to vanish the C2, if you add these two, C2 minus C2 here, it will vanish. So that's why I want to add this equation by this equation. Of course, you can add these two equations to find C1 and C2, because if you add them, here's 2C1 plus negative 2C1, it will vanish, so it will remain for you C2 as you like, but I will choose to add this equation by this equation. So 2 plus 3. So I want to add this equation with this equation. Then negative 2C1 plus negative C1, negative 2C1 plus negative C1. I have to write here this one plus this one, but since we know that if we add this equation but with this equation, this one, it will vanish with this one, so no need to write it. Equal equation 2 plus equation number 3. So here this 1 plus 2, 1 plus 2. Then of course I can write if and only if, but I will write like this. Here negative 2C1 minus, because plus with minus it will be minus C1 equal 1 plus 2, which is 3. Then negative 2C1 minus C1, which is negative 3C1 equal 3, because negative 2 minus 1, which is negative 3, and C1 of course here. Then I have to divide it negative 3 in both sides, so it will be C1 equal 3 over negative 3, because you divide it by negative 3 to vanish this negative 3, which is equal to negative 1. Therefore, C1 equal negative 1. Now we substitute C1 equal negative 1 by any equation here, 1, 2, 3, any equation, to find the C2. So substitute C1 equal negative 1 in, I will choose this equation in 3. Of course, you cannot substitute C1 equal negative 1 in this equation because here you don't have C1. So only this equations. Then here By substitute C1 equal -1 here, you will get here we have negative, and here we have -1 plus C2 equal 2. Then negative with negative it will be positive, plus C2 equal 2. Then you have to take this to the other side, so C2 equal 2 minus 1, which is 1. Therefore, C2 equal 1. So now we found C1 and C2. Now let's find C3 and C4. The same thing, I will add this equation with this equation. Of course, you can add this equation with this equation because here 2C3 minus 2C3, so you can add them to get rid of C3. Now let's add this equation with this equation to take rid of C4. To take out this C4, we have to add them. So equation number 5 plus equation number 6. Then the same thing we will do. Negative 2C3, negative 2C3 plus this one, negative C3. Of course, if we add them, this one, it will vanish with this one, so no need to write it. Equal -4 plus -5. -5. Then negative 2C3 plus with negative 2 will be negative C3 equal -4 plus with negative 2 will be -5. Negative 2C3 minus C3, it will be -3C3 equal -4 minus 5, which is -9. Then we have to divide it by -3 in both sides, so it will be C3 equal -9 divided by -3, which is negative with negative positive. 9 divided by 3, which is 3. Therefore, C3 equal 3. Now we found C3. To find C4, we have to substitute C3 in here, or in here, or in here to find C4. So let here substitute C3 equal 3 as we found it here. I will substitute it in here in 6. Then I will substitute here C3 equal 3 in here. So negative C3 equal 3. So here I will write here 3 plus C4 equal -5. I will take this term to the other side. So C4 equal -5. Here, since it's negative, it will be positive. So +3. Therefore, C4 equal -5 plus 3, which is -2. Now we found all C's. So C equal, as we called it before, C1, C2, C3, C4, as we did it here, this one, equal C1 equal -1, C2 equal 1, C3 equal 3, C4 equal -2. That's it. We found it. So it's very long solution, as we don't have a inverse, because here this one, it's not a square matrix, so we have to solve it like this. It's very long way, but you have to know that if you don't have the inverse of the matrix, you have to solve it like this. So in this example, we have to find this C by this way. So just as simple, we have to write C equal to this matrix, but you have to know the size of the C. If you know the size of the C, you have to write it like this. Then you have to multiply this matrix by this matrix. Then you have to compare it with this matrix. And if you multiply this matrix by this matrix, it will look like this. Then you have to write this one here again. Then you have to compare. So this one equal to this one as equation number 1. This one equal to this one as equation number 2. This one as this one, to call it as equation number 3, and so on. And this one, of course, here equation 4 equal to this one, and so on, like this. Then we found this C1, C2, C3 by adding these equations. Then you found it as like this. So we finish here. But now I want you to confirm that this C is correct. How to confirm this is correct? We have to substitute C here, so we have to multiply C multiply by A, and if it's equal to this one, then it's correct. Let's do it. To confirm C is correct. So we already finished, but now I want you to confirm that our solution is correct. As we know, we have CA equal B transpose. So I want to write CA, just CA, then it has to be equal to B transpose. C equal to this one, -1, 1, 3, -2. A equal to this one, 2, -2, -1. 2, -2, -1. Let's go up. 3, -1, 1. 3, -1, 1. Now let's multiply them together. Here 2 by 2, and here 2 by 3. So the result matrix, it has to be size 2 by 3. To compute the first element here, we have to multiply this row by this column. -1 multiplied by 2, which is -2, plus 1 multiplied by 3, which is 3, -2 plus 3, which is 1. So here I have to write 1. 1. To find this element here, we have to multiply this row by this column. -1 multiplied by -2, which is 2, plus 1 multiplied by -1, which is -1, which is 2, plus with -2 will be -1, 2 minus 1, which is 1. So here I have to write 1. To find this element here, we have to multiply this row by this column. -1 multiplied by -1, which is 1, plus 1 multiplied by 1, which is 1, 1 plus 1, which is 2. So here I have to write 2. To find this element here, we have to multiply this row by this column. 3 multiplied by 2, which is 6, plus -2 multiplied by 3, which is -6. 6 plus with negative, it will be -6. 6 minus 6, which is 0. So here I have to write 0. To find this element here, we have to multiply this row by this column. 3 multiplied by -2, which is -6, plus Negative 2 multiplied by negative 1, which is 2. Negative 6 plus 2, which is negative 4. So here I have to write negative 4. To find this element here, we have to multiply this row by this column. 3 multiplied by negative 1, which is negative 3, plus negative 2 multiplied by 1, which is negative 2. Negative 3 plus with negative, it will be minus 2. Negative 3 minus 2, which is negative 5. So here I have to write negative 5. Now let's compare this one with B transpose. 1, 1, 2, 1, 1, 2, 0, negative 4, negative 5, 0, negative 4, negative 5. So this one, it's equal to B transpose. So we confirm that CA equal to B transpose. So our C is correct. So this way how to confirm that your solution is correct, by computing the left side, then you have to compare it with the right side, which is B transpose. So that's it. In the next video, we'll do more examples of matrix inverse and transpose properties to help you understand these concepts in different scenarios. Feel free to comment below if you have any question or suggestion about this video. See you in the next video.